No talking unless if I'm asking you guys, what is X or whatever, y'all can respond. But other than that, I can't take any questions, none of that stuff. All right, chapter 1. So on constructions, if you guys still have your construction packet, you can go back over that and kind of look at that kind of stuff. Remember the main ones. If you're going to see a question on the test tomorrow, is probably going to be the perpendicular bisector goes 75%, that kind of stuff. All right, chapter 1. 1, 4, 9, 16. What is the 6th and 7th term? So all of those numbers are your perfect squares. So the 5th term would be 25. 6 would be
36.
7 would be
49.
49. All right, if I've got a bunch of different colors and shapes, what's the 13th color?
Right.
You've got to look at each different number. So if they're asking for color, I have 3 different colors. I have red, green, purple, red, green, purple. So every third one is a purple, right? So I'm looking for multiples of 3. 13 is not a multiple of 3, but what is? 12 is a multiple of 3, so the 12th one would be purple, so the 13th would be red. Okay. If they ask for the 40th shape, how many shapes do I have? I have 4. I have circle, triangle, square, diamond, circle, triangle, square, diamond. Every 4th one would be a diamond. Is that 40 is a multiple of 4, so the 40th would be a diamond. All right, all math teachers are bad teachers. What would be a counter example?
Not you.
Oh, thanks, Dana. Counterexample says, wait a minute, here's an example that disproves what you're trying to say. Stephen, you fell. All right, next thing, conditional statements. Conditional statement has an if and a then. If something, something, then something, something. So if I have a statement, vertical angles are congruent. If I want to throw this into make this a conditional statement, I have to have an if and a then. So I would say, if 2 angles are vertical, then they are congruent. I could go backwards. If 2 angles are congruent, then they are vertical angles. Biconditional has an if and only if. A straight angle is an angle that measures 180. How do I make that a biconditional? I could say an angle is straight if and only if it measures 180. Or backwards. An angle measures 180 degrees if and only if it's a straight angle. All right, converse, inverse, contrapositive. I'm almost certain you're not going to see a question on this, but we'll go over it anyway. I didn't teach this to you guys, so I have a couple of short little stories that I use when I taught this, but I had a co-teacher years ago that she said when she was younger, she would put her Converse shoes on the wrong foot. So we had this little inside joke, switch the Converse shoes. So converse statement, you switch the if and the then. Inverse statement, you put in the knots. Contrapositive, you do both. You switch the Converse shoes and you put in the knots. So example, if you study hard, you make good grades. Converse would be, if you make good grades, then you study hard. Inverse, you put in the knots. If you do not study hard, you do not make good grades. Converse, you do both, switch and put in the knots. So starting here, if you do not make good grades, then you do not study hard, or you did not study hard. Okay? All right, chapter 2, parallel lines and skew lines. You guys know what parallel lines are. Parallel to AD would be BC, FG, and EH. Skew lines are lines that are going in different directions and they're in different planes. So you think about the cars headed in completely different directions. So a skew line to BC would be DH. That's in a completely different plane. The cars are going up, these cars are going this way. A skew line to AE would be DC, HG. Remember, skew lines cannot touch. So AE and EH are not skew lines because they touch each other at. All right, our classic parallel lines cut by a transversal. Alternate interior angles would be 3 and 6 across from the transversal and inside the parallel lines. I've used a little hamburger analogy. Here's my hamburger. There's the buns. Everything outside the hamburger is exterior. Inside the hamburger bun is interior. Alternate exterior outside the hamburger would be 1 and 8, 2 and 7. Same side interior. They're on the same side of the railroad tracks. So 3 and 5 are same side interior, 4 and 6 are same side interior. They have to add up to 180 degrees. Same side exterior would be 2 and 8, 1 and 7. Corresponding angles are in the same spot in the window. So 1 is in the top left, 5 is in the top left, 4 is in the bottom right, 8 is in the bottom right. The little trick that I use with parallel lines, if 2 lines are parallel, all the big angles are the same, all the little angles are the same. When I say big, that means obtuse. When I say little, that means acute. 1, is that big or little?
Big.
8, is that big or little?
Big.
Then they're congruent. 2, is that big or little?
Little.
7, is that big or little? Then they're the same. If one's big and one's little, they have to add up to 180. So 1 is big, 6 is little. So they have to add up to 180. Okay, so you can use that trick when and only if the lines are parallel. Okay. Triangle sum theorem, all three angles of the triangle add up to 180 degrees. So on the green one, I've got 80 and 40, that's 120, so x would have to be 60. Over here on the purple triangle, I've got right angle here, I've got 72 here. So 90 plus 172, 90 plus 72 is 162, so B would have to be 18. If B is 18, then subtract that from 180, and A is also equal to 162. All right, this one here, you could use the remote interior angles on this one. You can use remote interior angles on this one. Remote interior angles, remote control, operates the TV on the other side of the room. So this exterior angle is equal to the sum of the two remote interior angles on the other side of the wall. Okay, so if you add these two angles together, 20 and 30, then that gives you 50. So y would be 50 degrees. If you can't remember that, then you can just use the triangle sum theorem and say this is 50, subtract that from 180, this is 130, and then these two have to add up to 180 because they're supplementary, and you still get 50. Those are your remote interior angles, equal to the sum of the two opposite inside angles. All right, chapter 3, CPCTC, corresponding parts of congruent triangles are congruent. You're not likely to see CPCTC on the exam tomorrow. They will probably write it out. Okay, I don't imagine they're going to use that acronym. All right, so chapter 3, everything was about congruence, congruent polygons, congruent triangles. So you guys learned back in chapter 3, this is called a congruent statement. So if I have these two polygons that are congruent, you don't have to worry about rotating them and flipping them. You can just use the congruent statement. Side HI is going to match up with which one? Well, instead of rotating that, just look at the congruent statement. HI is in the first two slots, so that's going to be congruent to what? LM. KH is first and fourth, that's going to match up with L and O. Angle H is going to match up with angle L. Angle K is going to match up with angle O, etc., etc. Okay, with your triangles, we talked about this last week, SSS, SAS, ASA, SAS. AAA is not one of them, SSA is not one of them. HL, hypotenuse leg, that only works on right triangles. All I need to know is that both triangles are right triangles, the two hypotenuses match up, and then one of the legs match up, hypotenuse leg. Okay, so let's look at some examples on that. The purple, how are those two triangles congruent? SAS. This one, always look to see, can I add arcs or ticks to my diagram? What can I add to that one? Angles in the middle, right, for vertical angles. So these two angles are the same, so those two triangles are congruent by ASA. This one here, I've got an angle, side, side, and side, side. How are those congruent?
No.
They're not, because this is ASS, which is a bad word. Okay, over here, can I add anything to the diagram? Ticks in the middle, so these are congruent by AAS. Okay. All right, isosceles and equilateral triangles. Isosceles triangles, two legs are the same. The regular isosceles triangle theorem says if you tell me these two legs are congruent, the regular isosceles triangle theorem says that means these two opposite base angles are congruent. If you go backwards and you tell me these two base angles are the same, and that allows me to put ticks in the legs, that will be the converse of the isosceles triangle theorem. Remember, converse just means we're going backwards. Equilateral triangle, all sides are the same. That means all these angles are the same. It's equiangular, equilateral, and the measure of all those angles is 60. 60, 60, 60, add up to 180. Okay, next one here, just some examples using equilateral triangles and isosceles triangles. Okay, so if these two legs are the same, it's isosceles, so that's 50, that's 50. Let's add up to 100, that means this vertex angle would have to be 80. Okay, 80. All right, this one is equiangular, so all sides are the same. So what do I do with these two expressions? So them equal to each other, 2x plus 6 equals 4x, move the 2x to the side, 2x equals 6, so x is 3. Always go back and... We all okay with it?
Yeah.
Okay, that's very distracting.
Sorry, taking my desk.
Okay. All right. Go back and check. 2 times 3 is 6, plus 6 is 12. 4 times 3 is 12. Always go back and check your answers. Okay. All right. Overlapping triangles. When you have two triangles that are overlapping, something's going to be shared. How are these two triangles congruent? I got to ask myself, where can I add stuff to my diagram? Is there anything being shared here? What's being shared? BC is being shared, so I could put 2 ticks on that. Overlapping triangles is always better to separate and redraw these things. So if I redraw the triangle on the left, I've got tick, box, and a double tick. If I redraw the triangle on the right, I have tick, box, double tick. Are those 2 triangles congruent? How? SAS, okay? Redraw overlapping triangles. Okay. Alright, transformations. I feel confident you're going to see a healthy dose of transformations on there. Okay, so if I've got a triangle here and I've got this point A, if I want to reflect it across the Y and then translate it down 5, if you remember the rule, great. If I'm flipping across the Y, then I change the sign of the opposite guy. So I change the sign of the X value. So this is sitting at -4, 6. So if you remember the rule, there's just +4, 6, that's fine. The easier thing to do is just count with your fingers. If I'm flipping out 1, 2, 3, 4 way, so 1, 2, 3, 4 way here. So that's going to be A prime. And then if I'm going to translate that down 5, 1, 2, 3, 4, 5, then my final resting place would be 4, 1. I imagine you're going to see some dilations on the exam. Just remember whether or not you're getting larger or smaller, if it's a reduction or an enlargement. Okay, chapter 4 with triangles. So we've had the triangle mid-segment theorem, which is if I have a line that goes through a triangle that splits these sides into equal pieces. So if these 2 sides are the same, these 2 sides are the same, then that is a mid-segment. So the relationship is that this guy is half of the base. Also, this guy is parallel to the base. So if these 2 lines are parallel, all that stuff from chapter 2 comes back into play. So that angle and that angle would be the same because these are corresponding angles. They're both in the top right of the window. These 2 angles would be the same. They're also corresponding. Mathematically, if they ask to solve for a side here, the way I teach this, this is equal to 1/2 of this, but the easiest thing for me to do is to just double this guy and set it equal to the base. If this is half of that, then it takes 2 of these guys to equal 1 of that guy, right? So I just double that. So if I double that, 10x, and then set that equal to the base, then I can solve for x, okay? And then go back and check your work. Plug that back in and make sure that that length is half of that. So if you multiply 5 times 4.5, that's 22.5, and yes, that's half of 45. Always go back and double check your work. Okay. Perpendicular and angle bisector theorem. Perpendicular bisector theorem says that if I have a perpendicular bisector, then any spot, any point on this perpendicular bisector is equidistant from these 2 points of this line. So if I draw a line here and draw a line here, those will be the same length. I will always be creating an isosceles triangle. If I pick this line, that distance and that distance are all the same. I can come down here. That distance and that distance are all the same. Okay, that's the perpendicular bisector theorem. Angle bisector theorem is the one I call the spider web theorem. So if I have a line that splits an angle in half, these 2 angles are the same, then any spot on this angle bisector, if I draw a line perpendicular to the rays, then those 2 lines will be the same. And if you pick any spot out here, if you just keep going, it kind of looks like a spider web. That's why I call it the spider web theorem. Okay, so that's the angle bisector theorem. All those links are the same. Okay, all of my children are bringing in peanut butter cookies. Okay, if you guys remember that. These are all of our points of concurrency. So all of altitudes orthocenter, my children, median centroid, are bringing in angle bisectors in center, peanut butter cookies, perpendicular bisectors, circumcenter. So the circumcenter is where all the perpendicular bisectors intersect. The importance of this point is that this spot is equidistant from all of the vertices of the triangle. So if I have 3 cities in my urban area, this is where I would want to install my cell phone tower, because all of these distances are all the same. Okay, I want to put this smack dab in the middle of these 3 cities so that all of my customers get the same amount of cell phone reception. So it's the same distance from the corners, the vertices of the triangle. Circumcenter, that's where all your perpendicular bisectors intersect. I doubt you're going to have to remember the actual names of this. If you're going to see a problem on the exam tomorrow, it'll probably be a mathematical problem where they'll say, you know, this will be some expression and this will be some expression, you set them equal to each other, something like that, if I had to guess. Your in-center is where all of your angle bisectors intersect. The importance of this spot is that the distance from here to each of the sides that forms a 90-degree angle, if that's 90 degrees, 90 degrees, 90 degrees, all of those distances are the same. That's your in-center. Okay, centroid is where all your medians intersect. A median is a line that goes from the vertex to the midpoint of the opposite side, splitting the opposite side into equal pieces. Okay, the significance of this point is that this is the center of gravity. This is the balancing spot. So if I cut out a triangle, if I drew the centroid and cut out a triangle, I could balance it right there on the centroid. Also, the importance of the centroid is that this guy, if I look at just this length, this guy is 1/3 the length, and the longer guy is 2/3. Y'all remember that? That relationship? So if this whole length, if I told you that that whole length is 12, and this length is 4, what would the long length be? This would be 8, right? This guy, this longer piece of the median is twice the short piece of the median. Or this guy is 1/3 of the whole length, or this guy is 2/3 of the whole length, however you want to remember that. Okay, orthocenter, altitude, not a whole lot of real world significance to this. This is just where all your altitudes intersect. All of my children are bringing in peanut butter cookies. Okay. Inequalities in triangles. Didn't get to teach you guys this. I used a little silly analogy of winner and loser. So if I've got inequality in one triangle, if these two legs, if all the angles are different and all the sides are different, then if you tell me that xz, if you tell me this length is greater than xy, so if you tell me this is 10 and you tell me this length is 8, then this guy is the winner and this guy is the loser. Okay, so the angles across from them will also represent the length of the line. So if this is 10, this is the winner. That means the angle across this guy, that angle is the winner. The loser here, the angle across from that, this guy is the loser. So if this length is longer than that length, and this opposite angle y is greater than this opposite angle z. Okay, winner and loser. All right, so if I look at this down here, if I got 3 different lengths here, which one is the winner? Here's the winner. All right, this guy is the loser. So the biggest angle is going to be across from the winner. That's the winning angle. This is the losing angle. And then this is like the middle one. So if I want to put these angles in order from largest to smallest, I'll go winner, middle, loser. So angle K is bigger than angle L, which is bigger than angle M. All right, reverse. If they give me the angles, if angle A is bigger than angle B, then this is my winner, and this is my loser. Then the sides across from that will correlate. So this is going to be the winning side, this is going to be the losing side. Okay, so BC is greater than AC. If I want to put these lines in order from largest to smallest, I need to know all the angles. I don't have all the angles. 58, 62, that means this angle has to be 60. So here's my winner, here's my loser. Okay, so the winning side is over here, there's the winner. The losing side is over here, there's the losing side, and this will be the middle. So if I want to put these in order from largest to smallest, let's say AB is greater than AC, which is greater than BC. Okay, the hinge theorem is inequalities in 2 triangles. Okay, so if I have a door here, if my door opens, okay, as that angle gets bigger and bigger and bigger, this opposite side gets larger and larger and larger. So if you tell me it's the same, I use the same analogy. If you tell me angle A is the winner is greater than angle X, winner, oops, loser. This angle is bigger than that angle, then this opposite side is going to be the winner, this opposite side is going to be the loser. So BC is going to be greater than YZ. All right, which one is the longer side? This is 7, this is 7, this is 4, and this is 4. Okay, so they match up, so I am allowed to use the hinge theorem. Hinge theorem just says if I have 2 sides that are congruent, but the angle sandwiched in the middle is different, then you can use the hinge theorem. And we have that here. 125 is the winner, 78 is the loser, so across from that, that's the winner, across from that is the loser. So line segment LN is greater than line segment PO. Chapter 5, this is the stuff I taught you. This is second semester stuff. So we have the polygon angle sum theorem. it says that the sum of all my interior angles is gonna be the n minus 2 times 180. If you guys remember the n minus 2, that's just the number of triangles that you can form in any polygon. And you multiply that times 180, because the three angles of a triangle add up to 180. So the sum of the interior angles of a heptagon is 7 sides, so I would do 7 minus 2 times 180, that's 5 times 180, that's 500 plus 400, that's 900. Each interior angle is the same formula, n minus 2 times 180, but I just divide by the number of sides, okay? So for what is this? This is a hexagon. I would just do 6 minus 2 times 180 divided by 6. The polygon exterior angle theorem says that, polygon exterior angle theorem just says the sum of all the exterior angles is equal to 360 degrees, no matter how many sides it has. One exterior angle will be 360 divided by n. So we have this little thing where if there's each in front of it, it's just the formula divided by n. Each interior angle is the formula divided by n. Each exterior angle is the formula divided by n. Parallelograms, this is all of our quadrilaterals and the relationships here. So parallelograms, opposite sides are congruent. Consecutive angles are supplementary. This is the big little. This angle right here is big, this angle right here is little. So one big and one little add up to 180. Opposite angles are congruent. This one's little, this one's little. They're congruent. This one's big, this one's big. They're congruent. Diagonals bisect each other, cut each other in half. Opposite sides, of course, are parallel. Okay, for a rhombus, it's all the same characteristics of a parallelogram in addition to these three. All four sides are congruent. Diagonals are perpendicular in a rhombus, and the diagonals bisect the angles. Okay. For a rectangle, of course, we got 4 right angles. Opposite sides are congruent, and the diagonals are congruent, but they do not bisect the angles. And then squares everything. Okay, trapezoid, if it's isosceles, these two base angles are congruent. If it's isosceles, the diagonals are congruent. And we have the mid-segment formula, which says the mid-segment of a trapezoid, if you got a line coming through here that cuts these two sides in half such that they're equal, then the mid-segment is 1/2 the sum of the bases. So I'll add that guy plus that guy and divide by 2, and that equals the mid-segment of the trapezoid. All right, for a kite, the diagonals are perpendicular, and we have 2 pairs of congruent sides, congruent consecutive sides. Chapter 6, ratios and proportions and similarity. Okay, so ratios, a comparison of 2 things by division. Sometimes you'll see it written as the colon, but most of the time we see it written as a fraction. So example here, if I've got a bonsai tree that's 18 inches wide, 2 feet tall, and they ask for the ratio of the width to the height, whichever one they mention first is the one that goes on the top. All right, so width goes on top. 18 inches on top, but remember, I gotta make sure these units are the same. So if I wanted to compare inches to inches, it's probably easier to convert this to inches. So 18 inches on top, the height on the bottom, which is 24 inches. Make sure the units cancel out and then simplify your fraction. These problems here, which says the ratio of the sides of a triangle in this ratio, when you see the colon, what did I tell you to put behind each of the numbers? X. So you put a little x behind each of the numbers. So I would say, and then I just add them up and set it equal to whatever we're talking about. If we're talking about the perimeter, I'd say 3x plus 4x plus 5x equals 98, and then solve that equation. If it says find the longer side, then whatever x is, I plug it back into 5 because 5 is the bigger side. Okay, similar polygons. If I have 2 polygons that are similar, this is not congruence. Okay, congruence, all the angles have to be the same, all the sides have to be the same. If it's similar, then the angles still have to match up. All of these have to match, okay, but the ratio of the sides have to be proportional. So that means that the ratio of that guy over that guy has to be the same as that over that, which is the same as that over that, which is the same as that over that. Okay? If you set up a proportion, you have to go, most of the time we go from left to right, you just have to be consistent. I can say AD over GH, but I can't go backwards. I can't say that's equal to JI over CD. If you go left to right, you gotta be consistent the whole time. Okay, side splitter theorem says if I have a line drawn in a triangle, this is not the mid-segment, okay? If I have a line drawn in a triangle that's parallel to the base, then the side splitter theorem says it splits it up, these 2 sides, such that they're proportional, okay? So in this example down here, here's the one where we said we're the boss. We can choose whatever proportion we want to set up. You just have to be consistent. I can go top left over bottom left. That's got to be the same as top right over bottom right. I can go top left over top right. 12 over 9 is the same as bottom left over bottom right. Okay, I could go bottom left over top left. Is the same as bottom right over top right. The only thing I can't do is I can't do Ghostbusters. I cannot cross the streams. I cannot do x over 9 equals 12 over 3. That's the only way you can mess these proportions up. And of course you cross multiply and solve. Okay. Dilations, again, I feel confident you're going to see something similar to this. All right, so if I've got a triangle and I'm dilating it, if I'm going from triangle ABC, the smaller one, to the large one, XYZ, then of course that's going to be an enlargement. And if you want to say this were an X here, we're trying to find this side, once again, you just got to be consistent. I can go 3 over 6 equals 4 over X. Or I can do 6 over 4 equals 12 over X. Okay. All right. Chapter 7, right triangles. All right, so Pythagorean theorem only works. Pythagorean theorem, special right triangles, trigonometry only work with right triangles. Pythagorean theorem, this one down here, I'm solving for the hypotenuse. So if I'm trying to find the hypotenuse, then I just square the two legs, add them together, and take the square root. Okay. If I'm finding a leg, I square both sides and do what? I subtract them. Okay. So this will be 8 squared plus 15 squared, take the square root of that number. This will be 10 squared minus 8 squared, take the square root of that number to get x. Okay? Special right triangles, 45, 45, whatever the two legs are is a isosceles right triangle. The hypotenuse is just the leg times the square root of 2. For our 30, 60, 90 right triangles, whatever the side is, this side is always across from the shorter angle. So this will be my 30 degrees. Oops. This will be my 30 degrees. That's my right angle. This will be my 60 degrees. So the short side is always across from the 30. So whatever the short side is, the hypotenuse is double that. Whatever the short side is, the long leg is the side times the square root of 3. If you can't remember that tomorrow, 45, 45, 90 has two different numbers, 45 and 90. There's your square root of 2. 30, 60, 90 has 3 different numbers. Here's your square root of 3. Okay, so this one down here, I'm trying to find x. This is 45, this is 90, that means this is 45, this is 60, this is 60. What is x? 60 times square root of 2. All right, here's my 30, 60, 90 right triangle. Okay, now this time they give me the long side, which is across from 60. This is the short side, this is the long side, and this is the hypotenuse. So if this is the short side, how do I get the hypotenuse? Double it, so this will be 10, and this will be 5 root 3. Okay. Trigonometry, you will have SOHCAHTOA on there tomorrow. You don't have to memorize it. It's on the formula sheet. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. Some old hippie called another hippie tripping on. All right, and so we've got example here, 17, 8, and 15. The cosine of A, I taught you to circle the angle and label. There's A, there's opposite, there's adjacent, there's hypotenuse. So the cosine of A would be what? 15 over 17. Okay, the tangent of B, circle, label. Tangent of B would be 15 over 8. Good. Okay. What is the cosine of B? 8 over 17. What is the tangent of A? 8 over 15. Okay, good. All right, let's do a couple examples. We're actually solved. Okay, am I solving for an angle or a side? Okay, so is that inverse or is that regular trig? Regular trig, okay. So first step is to circle the angle. You're not going to be able to circle on the computer, so draw yourself a little diagram on some scratch paper tomorrow. Label, this is opposite, this is hypotenuse. Which one has opposite and hypotenuse in it? Sine. So I say sine of my angle, sine of 40 degrees equals opposite over hypotenuse. When the variable's on the bottom, what do you do with that guy? Multiply or divide? Nope. You divide. When the variable's on the bottom, you divide. So x is 100 divided by that guy. Okay? If these were switched, if the variable's on the top, think about it this way. If the variable's on the top, how do I get x by itself? You just multiply both sides by 100, right? So when the variable's on the top, you just multiply by that. When the variable's on the bottom, you divide by the trig function. You're going to have your calculator cleared tomorrow. When it gets done clearing, you need to press mode and make sure you are in degree mode. Okay? If you're in radian mode, all that trigonometry stuff is going to be wrong. Okay. All right. So inverse trig is when I'm trying to find an angle. All right. So in this example here, find the measure of angle A. Step 1, circle. Step 2, label opposite and adjacent. Which one has opposite and adjacent in it? Tangent. So I'll do inverse tangent of opposite over adjacent, 41 over 100. Press enter, and it'll spit out the angle for you. Make sure you press second tangent to get the inverse. Okay. Angles of elevation, depression. Which one is the angle of elevation? Y. Angle X is the angle of depression. All right, chapter 8, circles. A minor arc has 2 letters, so minor arc would be BC. A major arc, you need 3 letters, that would be CDB. Central angle would be angle BAC, this central angle. All right, central angle. Measure of angle AB is 40 degrees, so the arc is 40 degrees. All right, circumference is pi d or 2 pi r, so if the radius is 6, the circumference would be 2 times 6 times pi, 12 pi. Okay. Arc length, these formulas are on the formula sheet. Arc length is the central angle over 360. It's going to be theta, a little theta symbol on the formula sheet. Theta over 360 times 2 pi r or pi d. All right, so think the percentage of the circle times their circumference. So in this problem here, it says find the length of x, p, y. Okay. So if this whole arc is 240, that means that this angle is 240 degrees. So I do 240 divided by 360 times pi times the diameter, which would be 30, or 2 times 15, 2 pi r. Okay, area of a sector is the central angle over 360 times the area of a circle, pi r squared. So if I want the area of this purple region, then I would do 62 degrees, which is the central angle, 62 over 360, times pi times the radius squared. This 14 is the whole diameter, all right, so it would be 62 over 360 times 7 squared pi. All right, inscribed angle, if the vertex is sitting on the circle, then this arc is half of the angle. So if this arc is 170 degrees, half of that would be 85. Okay, so if this inscribed angle is 30, then this arc, you would double it. This would be 60. Okay, angle formed by 2 intersecting lines. This angle, this interior angle, is just the average of these 2 intersected arcs. So if this is 40 and this is 70, what is the average of those 2? That's 110 divided by 2, that's 55, that would be the average. If they give you the interior angle and they ask you to find one of these arcs, just remember this is the average of 30 and this angle. So 40 is halfway between 30 and what? 50, right? All right, so, circumscribed angles. All right, so you got your exterior angle here is equal to 1/2 of big minus little. So angle 1 is equal to 1/2 of big minus little. 160 minus 40 is 120 divided by 2, 60. Chapter 9, volume. Not a whole lot to say about volume. The formulas will be on the formula sheet here. So volume is base times height. Alright, so the volume here is, the volume of this triangular prism would be the base times height, but this is a triangular pyramid. So what's the easiest thing to do on this one? Yeah, I just do, the area of a triangle is 1/2 base times height, so the volume would just be 1/2 base times height times the length. So I would just do 3 times 4 times 10 and just divide by 2. It's just half of a rectangular prism. Cylinder. I'm not gonna spend more time on volume. You know, just plug in the numbers into the equation. There's nothing else to do here. Sphere, 4/3 pi r cubed. That's easy. All right. Chapter 10. We took this out. That's right. We took this out. We took all that out because that's not in there anymore. Okay. Chapter 11. Name by degree and term. This is what the very first thing you guys did back in August. Okay, what is the degree of this polynomial? It's actually a monomial because it's only one term. What's the degree? Alright, this is tricky. Monomial is the only one where you add the exponents. Okay, so this is a 5th degree monomial. Anything after that, you look at the highest degree. Okay, so this one here, the highest degree is, so you would call that a, what kind of trinomial? What do you call 3rd degree? Cubic. This is a cubic trinomial. 2nd degree would be a what? Quadratic. So this one down here would be a quadratic binomial. Okay. 1 term monomial, 2 terms binomial, 3 terms trinomial. After that, we just say polynomial. Okay. 1st degree is linear. 2nd degree is quadratic. 3rd degree is cubic. Technically it goes quartic, quintic, but after that we just say 5th degree, 7th degree, 20th degree, whatever. Okay, adding and subtracting polynomials, all you do is just combine like terms. Alright, so I got 2 apples plus 2 apples plus 6 apples, that's 8 apples. So 8x cubed. I have 3 oranges minus an orange, I have 2 oranges. 5 minus 4 is 1. When you subtract polynomials, what do you gotta do with this negative sign? You gotta distribute. That means you flip all the signs of these. So this will be x cubed minus 3x squared plus 5x minus 7x cubed minus 5x squared plus 12. And then I just match up. I've got 1 apple minus 7 apples. I have -6 apples. I have -3 oranges minus 5 oranges. I have -8 oranges. I have 5 bananas. And I have plus 12. Okay, just combining like terms. Okay. Factoring GCF. What is the GCF up here? It is not 5. They all have an X, so I can pull out an X. So the GCF is 5X. All right, distributed property. When you multiply these, I always do coefficients, and then I do the signs and the coefficients, and then the exponents. So 8 times 7 is 56. And what do you do with these exponents? Add them together, so that's y to the 5th. Distribute here, that's going to be, get the signs right first. Negative times a positive is negative. 4 times 8 is 32. 3 plus a 1 is y to the 4th. Distribute here, get the sign right. Negative times a positive is negative. 8 times 1 is 8. And I just have 8y to the 3rd. Okay, that's baby stuff for you guys. Okay, factoring. All right, when you are factoring in this form, ax squared plus bx plus c, when that coefficient is a 1, all you do is what are the factors of the c term that add to the b term? So what are the factors of 24 that add to 11? 8 and 3. So this will factor as r plus 8, r plus 3, okay? This is not an equation. I'm not setting this equal to 0. Okay, I'm not solving anything. I just want to factor it. If I want to factor 6, that factors as 2 times 3. This factors as r plus 8 times r plus 3. All right, second one here, when this is a negative, that means one's negative, one's positive. What are the factors of negative 21 that add to negative 4?
7, -7 and 3.
Okay, which one has to be negative? The bigger one. So this factor says x minus 7 times x plus 3. factoring when a equals 1. Alright, factor when a is not 1. Okay, this is when you gotta do the rainbow thing. Okay, 4 times 3 is 12. What are the factors of 12 that add to negative 8? This is positive, so they both have to be the same sign. Negative 6 and negative 2. So I'm going to split that. I'll put the 2 over here. 4x squared minus 2x minus 6x plus 3. I just split negative 8x into negative 2 and negative 6. Then I can draw my curtain. I can pull out a GCF of 2x. That will leave me with 2x minus 1. What do I have to pull out here? If that front coefficient is negative, you must pull out the negative. So I got to pull out a negative 3. That better leave me with 2x minus 1. It does, so my two factors are the matching parentheses and the stuff left over on the outside. 2x minus 3. Okay. Quadratics, here are my 7 ways to solve here. GCF, then special cases, difference of squares, then the square root method, then a is 1, then a is not 1, grouping, the quadratic formula, and completing the squares, last resorts. Okay, how do I solve this? This is GCF because there's no C term. So all I'll do is pull out the GCF, which is 5x. That leaves me with x plus 2. When I pull out a GCF, one of my x's is always 0. If I set 5x equals 0, I get 0, and then I flip that sign, 0 and negative 2. Difference of squares, this factors as 1 is positive, 1 is negative, and then flip the 2 signs, x equals negative 3 and 3, plus or minus 3. That's your difference of squares or special cases. Okay, square root method, I just want to get x squared by itself and then take the square root. So I divide both sides by 5, x squared equals 25, take the square root, and x is equal to? 5. It is not 5. It is plus or minus 5. Remember, in quadratics land, 95% of the time we're going to have 2 answers. Okay. Sometimes we might not have an answer at all. Sometimes we might only have 1 answer, but most of the time you have 2 answers. All right, factor when a is 1. Factors of 5 to add to 6?
1 and 5.
5 and 1. X plus 5, x plus 1. Now I have an equation. Now I flip these signs. Negative 5 and negative 1. Okay. Grouping. I'm going to have 4 terms. All right, so curtain, pull out a 12x. That will leave me with x plus 2. Pull out a negative 6. That better leave me with x plus 2. Yes, it does. Matching binomial is one of my factor. Stuff on the outside is the other factor. 12x minus 6. Here I can just flip that sign because there's only a 1 hitting 1 in front of the as a coefficient. So that's just negative 2. Here I actually need to set that equal to 0. So 12x equals 6. X equals 1/2. You could have also pulled out a GCF on the front end. You would have got the same answer. Okay. Quadratic formula. Do I need to do one of those? Y'all are good with that, right? Just plug the numbers into the formula. All right, we're close. We're close. Completing the square. All right, so completing the square is where I'm going to have a blank here. So x squared plus 10x plus a blank equals 11, and then another blank. Okay, so half of b squared, half of b is 5, 5 squared is 25. So if I have a plus blank on the left, I will keep a plus blank on the right to keep my equation balanced. This factors is half of that number. So x plus 5 squared equals 36. Now I can take the square root of both sides. X plus 5 equals plus or minus 6. I've got 2 different answers. So plus or minus 6. And one of my answers is x plus 5 equals 6, which means x is 1. My other answer is x plus 5 equals negative 6. And that will be negative 11. So my 2 answers are 1 and negative 11. That to me is a last resort to solve a quadratic. Quadratic formulas to me is much easier than completing the square to solve. Now to put a quadratic vertex form, you are going to need to know how to do that, but that's the one where both blanks are on the right hand side. So you have like a plus 7, you would offset that with a negative 7. That's completely different than solving a quadratic by completing the square. Okay, circles, here's the equation of the circle. So x plus 2 squared plus y minus 1 squared equals 16. What is the center?
Negative 2, 1.
Negative 2, 1. Flip those signs. What's the radius? 4. Good. Okay, this is how you find the x-coordinate of the vertex of a quadratic, negative b over 2a. So the vertex of this one, there's my b, so negative b over 2 times negative 1, negative 2 over negative 2, so the x-coordinate would be 1. To find the y-coordinate, I could just take this value and plug it back in here and find the corresponding y value. And that's how I can find the vertex of any quadratic, negative b over 2a. Okay. Solving a system of equations, you have something like this. I did one of these last week, didn't I? You just take this expression and plug it in here for y. So I'll have 2x minus 3 equals x squared minus 3x plus 3. You got a quadratic, set it equal to 0 and solve. All right, and then we get to probability, which hopefully is fresh in your mind. Okay. I made it. I made it. All right. Get a good night's sleep tonight. Watch parts of the video if you need to. Any last second